Hello viewers, welcome. So in this tutorial I am going to show you how to perform classification of image through single layer of perceptron, and in the next tutorial I will be showing you how to make the model. But in this tutorial I am going to take help of Keras, Tensorflow Keras, so that it takes less of time. So for better intuition, follow the next tutorial. So let's begin, let's dive in. Okay, let me make a new one. So go out there. Okay, just import. Start with importing. So import TensorFlow SDF, and I'll be using, so write out there X train data, Y train, write out there X test, Y test, and write out the Tensorflow Keras dot datasets dot mnist dot load data. Now I am going to show you few of the image for I in range of 25. Now so let's see image plot dot subplot. Write out there 5,5 I plus 1. Now plot dot imshow, write out the X train out there and pass out there, give out the X space instead of X train. So okay, now plot dot show. So let's see. Okay, I have to take help of matplotlib. So import matplotlib dot pyplot as plot. So you can see these are the data. I have printed 25 data out there. So mnist data set, which is of handwritten data, and now I want to make a neural network which will predict the images, and it will say what kind of digit it is. So let's do so. For that reason, create a model. So model equal to write out there Tensorflow Keras dot layers dot what should I give, sequential. Okay, now sorry, Keras layers is no. Okay, sorry, I have to give out their models. Okay, now I want to add few, so perceptron. So model dot add. So you can if I see okay, let's add another cell out there. So let me show you. So let me show you the size of image dot shape. So you can see it is 28 by 28 image. Now I want to flatten that image. Okay, so for that reason I have to add a Keras dot layers dot flatten. So it will flatten the data. Now give out the input shape. So input shape will be, it will be of 28 by 28. Now add another one. So model dot add. Now tf dot Keras dot layers dot I will be using a dense layer, so dense, and I'll be using 10 neurons out there, perceptron neuron, what you say. So I'll be giving a activation function. So activation will be softmax, okay, 10 softmax, okay, fine. So my model is done. Now I have to say my model how it will compile. For that reason, compile and give out there uh, okay, loss function. So loss will be okay, loss will be okay, before that, okay, just continue. So tensorflow dot losses dot binary cross entropy, binary cross entropy, fine. This is what I am going to do now. Optimizer, so define a optimizer over there. Optimizer equal to Adam optimizer will be fine. Then I want to track the matrix, so write out the accuracy, fine. So my model is done, compilation is done. All I have to do to feed my data. Okay, so before doing so, I want to make another thing, that is you can see if I show you the data shape out there. So x train dot shape, so it is a 60,000 data out there, and y train out there, oh sorry, dot shape, and you can see there are 60,000 data, the outputs. But if I show you one of the output out there, train 0, let me show you, and you can see it is 5 out there. So I want to change this to one hot encoding. So what is one hot encoding? I'll show you this one. So y train equal to tf dot one hot, and pass out there y train, and there are 10 classes out there. So for that reason I have given 10 y train, okay, also one hot out there. Okay, now let me show you y of train out there, train 0 out there. Let me show you what's the problem. So one hot I have encoded to 10. Okay, I have assigned out there wrongly. So you can see it is converted to a tensor, and you can see 0 1 2 3 4 5. So when the 5, so only my fifth number data is on, and rest of the all the 10 elements or the 9 left elements are off. So this is what one hot encoding is doing, and the reason is that I have used a loss function of binary cross entropy, so it can detect switch between 1 and 0. So okay, fine. Now I have to feed the model. So model dot feed, pass out there x train and y train, and give epochs out there. So epochs equal to 5 should be fine. Okay, so let's wait for a while. Okay, so it is doing it, and you can see out there in the first epoch the accuracy is near 40%. In the second epoch it is near 53%, and so it is gradually increasing. Okay, in the fifth I got only 68%, so I should increase this one. So let's make it 10. So wait for a while and see, I am gradually increasing my accuracy out there. So let's wait for a while. So you can see out there I got accuracy near 71%. So I'm not satisfied with this. So I want to change my data. So you can see this is my data out there, and there is x train and y x test out there. So I want to normalize the data. So x train, x test out there, and x train divided by 255.0 and x test divided by 255.0. Okay, now I want to feed the model again. So let's feed the model. So model dot feed and pass out there x test, x train and y train out there. So give epochs, let's give 5, and you can see now I am getting higher accuracy out there. Okay, so you can understand the value of normalization from here. Okay, I got a pretty good accuracy now. Okay, now I want to plot my data, see how my model works. So prediction, okay, equal to model dot predict, pass out there x test out there. So I'm passing x test and give out there. Okay, that's fine. So let me show you. So prediction. So there are 10,000 data in X test. Okay, so let's see one of the data, and you can see in one of the prediction there are what should I say, 1 2 3, and for 10 neurons there are 10 outputs. So I want to find the maximum value from here. So for that reason, so I want to find the index of maximum value from here. For that reason, what I can do, argmax pass out there and give out their prediction 0. Okay, prediction 0, argmax is okay. I have to import another one. So import numpy as np and use out there np.argmax, and hopefully I will get one. So you can see it is predicted as so the index is 7. So if I see the class name, so let's give the class name out there. So for the first one it is 0, so the second one is 1, and the third one is 2. So you can just write this one. So these are the class names out there. Now I want to, okay, so these are the class names. Now just pass out there class name equal to I want to pass out there numpy.argmax of, let's give out there prediction 1. So let's see. So it is 2, and now I will show the image. So just show for I in range of 25. Okay, so plot dot subplot out there and give out there 5,5 and I plus 1, and plot out there im show and give out there the image. So I want to x test out there. So this is the image which I have passed out there, and I want to also label the image. So x label, give out the x label, and I want to label with this class name. Okay, so for that reason, so class name and pass out their numpy dot argmax and pass out their prediction and I. Okay, so and plot dot x ticks out there, keep out there blank. Okay, so I'm done. Just out there plot dot show. So let's see what I got, and you can see okay, I'm not showing out there, so let's give a bigger size out there. So plot dot figure and give out their fixed size and give out their 8 by 8. So let's see what I got, and you can see this is the 7 handwritten 7 out there, and this is the prediction, and this is 2 out there, and this is the prediction, this is 1 out there, and this is the prediction 0 0 4 0 9 9, and this is 6 out there 6, and this is 9 out there 9. So this is how I can take help of Tensorflow Keras to build a model and do classification. In the next tutorial I will be showing you how to make this similar model but without taking help of Tensorflow Keras. I will be doing all the functions through Tensorflow arrays. So see you then. As always, thanks for watching.